Hello girls, today we want to start with the radio waves. They come at the beginning of the electromagnetic spectrum because they have the longest wavelength and the lowest frequency. Let's start. Radio waves are part of the electromagnetic spectrum. As we said, they have the longest wavelength and the lowest frequency. They are radiated from aerials and used to carry sound, pictures, and other information over long distances. The main use for radio waves is for communications. Okay, so we use radio waves for communications. We have more than one type for radio waves. The first one, radio waves, that the wavelengths of them is between 2000 meter to 10 meter. You remember the wavelengths? Yes, these types of radio waves, they have a wavelength range between 2000 meter to 10 meter. We call this type long, medium, and short waves. This is the first type. The second type, they have wavelengths between 10 meter to 10 centimeter. We call them very high frequency or ultra high frequency waves. The third type, the wavelength is what? A few centimeter. So very short wavelength for radio waves, and all these are radio waves. Okay, now we know that radio waves, they have the longest wavelength in the electromagnetic spectrum, but we don't have only one type, we have so many ranges for the wavelength. Okay, so there are three types, so I'm going to talk about them one by one. Now the wavelengths of a few centimeters, they are what? Microwaves. So sometimes they combine microwaves with radio waves because they share the same properties, okay? So the type of radio wave that has wavelength of a few centimeters, we call it microwaves. Let's start with the first type that has wavelengths of 2 kilometer or 2000 meter to 10 meter. Okay, what did we call this type? Long, medium, and short waves. Why we call it long, medium, and short? Because look at the range, 2000 meter to 10 meter. Long, between here, medium, and like 10 meter or 10 is what? Short waves. The properties for these waves, they can diffract around obstacles, so can be received even when hills are in their way. So this type of radio wave can what? Bend around obstacle. They can diffract. You remember diffraction? Yes, this type can diffract. That's why even if the source of the wave is here, radio wave, it can reach this part. Why? Because the waves, they can diffract and they can bend around obstacles. They are also reflected by layers of electrically charged particles in the upper atmosphere, the ionosphere. Here, you know atmosphere, right? We have here at the top of the atmosphere layer, we call it ionosphere, okay? Which makes long distance radio reception possible. Look at this video.
Lower frequency radio waves are reflected by charged particles in the upper atmosphere.
So what happened here? The radio waves, they can transfer to long distance because they reflect. They don't continue moving in a straight line to the space. They reflect by this layer that we call it ionosphere, and they reach the other part. Okay, these are the two properties for this type of radio waves. The second type, wavelengths of 10 meter to 10 centimeter. What did we call this type? Very high frequency or ultra high frequency waves. These shorter wavelength radio waves, need a clear straight line path to the receiver. So they don't diffract, they don't bend around obstacles the same as the first type. They need a clear straight path to pass through. There's any obstacle in front of them, they cannot pass or bend through this obstacle. Okay, this is the first property for this type. The second one, they are not reflected by the ionosphere. Remember the first one? We said it reflects by the ionosphere. Here it cannot be reflected. Watch this video.
Higher frequency radio waves, like UHF waves, are not reflected and carry on travelling through space.
So these, they can continue traveling and they can reach what? Space. That's why we can use them where? For local radio or television. Okay? That's why sometimes while you are in the car listening to the radio, and you enter a tunnel, for example, what happens to the radio? You cannot hear properly. Why? Because this type of wavelength, they cannot bend or they need just a straight and clear path to pass through. Okay? The last type, which is wavelengths of a few centimeters, we said these, what are they? Microwave. It's one type of what? Electromagnetic spectrum. These are used for international telecommunications and television, and we use them also for mobile phone networks. Microwaves are also used for radar detection of ships and aircraft and in police speed traps. And also microwaves can be used for cooking. Here, like this one, microwave ovens. We all have these microwaves at our houses because they cause water molecules in the moisture of the food to vibrate at the frequency of the microwaves. As the result, heating occurs inside the food which cooks itself. Okay, this is how the microwaves work, how they cook the food quickly and easily. Dangers or harmful side effects for microwaves in general: living cells can be damaged or killed by the heat produced when microwaves are absorbed by water in the cells. Okay, this is the danger or the harmful side effect of microwaves. Look at these examples. Where do we use microwaves? Satellite communications, television, mobile network, radar communication, microwave ovens. All these are examples for microwaves. I hope that this part of the lesson is clear and easy.